Yes, we are live. Uh, Maybe Eric, you can give a recap of last week, what was done, and then we can continue.
I guess so. Last week we had a session just without you and YaRG, okay, all the others, okay, and we talked about two topics. So one of them was the Sony's Presence platform. Okay, I say platform because it's a board a bit like the Raspberry Pi Pico. Okay, but they have a set of sensors, extensions, and an SDK and so on the Notix operating system. Okay, and the second half, I will need help here. What was the second half?
It
I
was
forgot.
the LiDAR that Anuraj
LiDAR.
found. I have
Yeah.
one as well.
Yes.
We looked at the specs and just went through like the market of LiDARs and what they cost and how they work, things like that.
Yeah.
So TLDR it goes on top of a Raspberry Pi with ROS, and seems to be like not much updated Git repo for it, and it looks like an older sensor. Maybe that's why many were available cheap. So making it work will be interesting.
It's a UART based LiDAR. So, and the plugin board I had made, so there are pins on it so that you can connect it directly.
Okay.
And well, the driver needs to be written, but it's basically you could port the Raspberry Pi driver to a C port on the ESP32.
Okay, that works. And also the pin, like the hat-like thing that you gave me, that'll fit an ESP32. It looked like an RPi-sized uh, hat. The one.
No, so basically you could fit it on the tumbler on top of the tumbler, just place it on the tumbler, and then there are four sockets pins coming out from that LiDAR, and that should directly go to the side of that plug-in board I sent.
Okay, I mistook it for an RPi hat. Okay, so this is already set up for ESP32. All right, that sounds good.
Yeah,
All right,
and
that's
then yeah, the software is not there, but
the software. It's never quite there, is it?
Never.
yeah, but we could ask, like, I started using Claude now, and then probably it should be able to read the data sheet and write something. I'm just guessing, because it's really good. At least in ROS based codes, it is like it gives out quite decent stuff. And then there is some correction needed, but yeah, it's good enough.
we did have like a informal discussion of like this whole problem of software and should you choose platforms that have a lot of support. Like this came up with the Sony versus RPi discussion. The Sony chip has lots of nice features, but we got into a discussion of like, should you ever build on that, given our experience with BeagleBone and others, or should you always go for the versus better widely supported platform? So that was an interesting discussion we should pick up at some point.
Yeah, but the ROS code should work with the Raspberry Pi, most of it, I guess. At least for this LiDAR. Yeah, and I don't remember where Mayor was stuck. It was some COM port thing, right?
Yeah, he couldn't find the place we're supposed to send the data. There was a any file which defined, stuff like weird uploads to, and it said, unable to find.
Okay, I wasn't able to test it on Windows. I haven't had time, but we can try it again. Or if Venkat has something set up, we can try to set it up on his Mac. You are muted.
Sorry. No, I haven't yet gotten around to it. I just got off 3 hours of evening meetings just now. So next few weeks sometime I'll try to make time. But yeah, okay. So nobody has anything prepared then?
No.
Let's do a live debugging setup session.
I may have a topic also to talk about, okay, depending on what we want to do, okay. It's more about a design question on how to build a rover for a specific use case.
Okay.
Let's go with Eric's. I think
Okay.
I can try to set up the Windows thing on my side by next week, and then we can debug live for Mayor next week.
So, sorry to be mysterious, it's just that I have prepared one slide to explain the problem. The problem is that I can't share my screen without restarting the browser.
If you send one of us your slides.
Sorry, I just need to share it. Here we go. I sent to the private chats. Okay. So
Who's sharing it?
I said not.
No, I'm saying who's gonna bring it up.
I can share it.
A volunteer.
Okay.
Okay, so I live in the mountain, but I live in a mountain. I will explain what this is. Huh? Okay, basically, I'm surrounded by rice paddies. Okay, so we can see beautiful pictures in Thailand and in China. Okay, where you have these valleys. Okay, it's a nice slope. Okay, but basically they build huge stairs. Basically, okay, where each stair is a rice paddy. Okay, and so. There is something that I've seen very often is here, at least in Japan, but I guess in every country with such kind of architecture, okay, they really take care of it really, really carefully, okay. And so one of the things is to cut grass, simple, okay. And so, but the thing that the
grass or rice,
grass, okay, around the paddy, okay, they take care of the around the paddy. Inside the rice paddy, basically, it's water. Okay, so this is what you can see on the slide on the left hand side. Okay, you have water like something like 20 centimeters deep, and you have all the rice at a regular interval planted there. Okay, and it's surrounded by a small dam basically to keep the water. Okay, and usually along those paddies you have a river. So the one you have in the middle. Okay, you have a river along them. Why a river? Is basically to they use the river to fill the paddies and to empty them at the end of the season and stuff like that. Okay, and so the problem are the white area. So please imagine this slide that it's I cut the ground and we see that from the side. Okay, so everyone knows how to use a CAD software here, so it should be easy to imagine. Huh? Okay, and so. The problem is when they take care of the grass, okay, it's the white part in the middle, okay. So the small dam, and after, it's not so large. It's about maybe 30 centimeters, usually, just for someone to walk. And after it's quite like 45 degrees or a bit more slope down the river, okay. And after you have another slope, and after it's usually a road, okay. And so the problem is to cut the grass there. And so you can see these guys, and these guys, they are usually men, okay, but in their 70s, okay, and they come with their hand lawnmower, okay, they catch it with one hand, okay, and they cut the grass everywhere, okay. Okay, so here's the problem. If it's interesting to discuss it, is that how can we make a rover that could cut the grass on those slopes, basically?
I have a silly question, perhaps. Is if the dam is so standard, why don't you just have a lawnmower that rides on the dam?
There is not so much space, okay? So I would say the middle part,
it's 30 centimeters wide, and it has two arms on either side to align it with the walls of the dam. Or is it not that standard?
And so that's the kind of idea that I think would be interesting to discuss here, okay? Because that's a possible design, but no one has ever done that, at least in what I've seen around, okay, or what I'm aware of. And in this group, we've discussed in the past about tires, but also about legs versus tires and so on. And for example, legs can be very interesting in for some terrain, okay, but there are problems of durability and stuff like that. And so in agriculture, usually people, they want to buy a machine for at least 10 years, basically, okay, like a tractor. So I wonder whether that kind of design, which I think is very interesting, appealing, but I wonder whether it's a durable, perhaps in a out of fashion way of thinking, perhaps.
So do you have any pictures you can show us of what the dam looks like, so we can see how uniform it is, if it has rocks on it?
Yeah, so I'm sorry. Actually, I thought about making this slide just half an hour ago, and I thought, a picture would be great. And it's just I have to walk 100 meters. Okay, that's it to get some. Okay, but I don't have right now. It's just I can see on the regularity that these paddies can be they're usually pretty big, like 50 to 80 meter. So sorry, how it is in yard and so on. Okay, but you get the idea. Okay, it's like a swimming pool. Okay. For a typical swimming pool in terms of size or bigger. So it's and around there it's very flat, because they want to keep the water very calm, okay, calm but still flowing, to bring nutrients to the rice, okay. So it's pretty flat. So in that sense, the slide shows a cut, okay, but so in that direction, okay, it's pretty flat. It's just on the to cut on the slopes of the river.
Anuraj, can you click on the link I just shared? Yeah. The picture, Eric, tell me if it's correct. The picture all the way on the right on the top row, that's a typical picture.
So maybe yes, that one gives the idea. Okay, it's very typical. If you can make it bigger, we can understand. Usually, it's better to go back to your Google search, and you have a view image button somewhere where usually it can show it bigger. But here we can see on the left-hand side the paddies, okay, and on the right-hand side the road I was talking about, and in the middle the tiny river, okay. But we can see the slopes can be really big on the side of the river. Okay.
So here's what I'm trying to understand. First of all, I notice it's a grass is growing on all four sides of the paddy. So do you want to cut all of that grass? And the second thing is the slope of the road also has grass on it. Do you want to leave that grass?
So what the people do is that they cut the grass everywhere, because it's pretty humid in Japan. Okay, not as much as in Thailand and so on. Okay, but still, the grass grows very fast. Okay, if you leave it a couple of weeks, okay, basically it obstructs the river. Okay, it starts obstructing. It's not yet obstructing. Okay. So that's why they cut well. They really take care of that, and the goal is to unobstruct the river, because the river is vital for the rice paddy, to bring nutrient. Okay.
So the issue is the river, not the. Anurag, can you put back the slide? Okay. So the issue is not cutting the grass on the dam. It's making sure that the river doesn't have any grass, falling into it or blocking it.
Right, and so that includes the dam, because the river is along the dam. Okay.
No, but if I were to ride inside, actually, it's more like a canal. If I ride inside the canal, and I clean up all the grass next to me, so that it looks like the picture we just looked at before, that's good, right? I don't need to get rid of the grass. I just need it to look like the picture we had before, that the canal is not blocked.
Right, and so, but in practice, that we just saw an example, but in my observations, okay, in practice, it means, removing the grass from the two slopes along the river, okay? And it's the picture we saw is typical. but you have a lot of variability as well, typically on the slope, and how to access the slope as well. Okay.
What I'm
Is
trying
the
to say.
stream on the side really deeper than the paddy field?
Yes, really deeper. Usually, you see, I show a kind of depression, okay, where the river is really under the paddy. It's typical case, okay. One of the reasons is because, at least in Japan, but I think in many countries doing rice, there can be heavy rains, especially in summer, okay. And so then, it floats really easily, and so they want to protect the paddy as well.
So you want to cut grass on both the sides or just one side?
Yes, on both sides, but
Both the sides.
both sides of the slope, okay. And so the slopes can be 45, 60 degrees sometimes, okay. Yeah, and sometimes on the roadside, most often the roadside is really vertical, okay. So then, but in that case, there is almost no grass growing there, okay. So it's not the problem anymore.
What energy budget do we have? In other words, is there any cost associated with having energy? If I had a little boat going down the canal and it had a flamethrower and it would burn grass on either side, I mean, is that a energy problem, a cost problem? Can you give us anything about these parameters?
So what I can say that there is variability. There is variability on the canal itself. Okay, so it can be more or less wide. Okay, but there is a minimum because they need a certain flow. Okay, so I would say, usually it's at least around 10 inches. Okay, if I convert correctly. Okay, it can be bigger. Okay, but around that. Okay. The thing that it can become narrow and wider like that, and sometimes very wide. Okay, some of them are usually at the end, toward the end of the padding, it gets larger. To get the water to flow away as soon as possible because of floods. Okay. Oh, by the way, once I saw a tsunami going up one of those, the result of a tsunami going up one of those, okay? That was super impressive, you have a slope down and you see the water going up, okay? That's, by the way, okay? So a boat could be an idea.
I have an idea I want to throw into the conversation here. Remember seeing lots of interesting photos long ago of Japanese rice harvesting machines, which I remember stuck in my head because in most rice growing countries, it's very heavy manual labor. It's like literally humans doing it. But in Japan, apparently, they use rice harvesting machines. I put a Google search there.
Yeah.
But rather than thinking of like designing a whole new rover, can we think in terms of an attachment for one of these machines? Because in the US, that's kind of how farm equipment works. There's these general purpose, combine harvesters or John Deere tractors, because it's like very large scale. Unlike Japan, it's very wide, big fields, lots of room, but still it's an interesting strategy. You have like one general purpose vehicle to which you attach lots of different attachments. So I thought rice harvesting machines might be a similar platform. Like you could imagine attaching like a little angled cutting tool to the side of one. They're already designed to go through the terrain and navigate whatever the farm topology is. So why not attach a cutting tool? Is that a viable?
For me, that sounds a possibility. So we can see this machine. Okay, there are plenty of those here. Okay. And they are quite exactly what Venkat said. Okay, so we can adapt. It's a multi-tool basically. Okay, that's an idea, definitely. Okay, to have some kind of arm that would go down, because we saw at the beginning of the video that there is a river on the side, and actually on the roadside it's a vertical, as we talked about earlier. Okay, but to do the same, the two at the same time, could be interesting. Then one thing is that those machines, are decades running designs, okay, and so not sure how flexible they are, because they have their use cases. Okay, after, is this a clear API, hardware API? That I have no idea. Okay. After, there is a problem of weight. Okay, because these machines they are small. In Japan, a lot of things is small because the country is just so narrow. Okay. And for that, it's very impressive how compact they are. Okay, but still they are very heavy. Okay, when I see them arrive, to the paddies I see just from my window. Okay, it's like a big truck coming and the thing going very slowly to enter the paddy and so on to not damage anything because really heavy. Okay.
But these are manually driven, right?
Yes. Yeah.
I don't know. I'm looking at a Korean patent, and the translation is iffy. If you want, I'll put the link on. Oh, and what he says is that there's scroll down a little bit. Yeah, but stop. Just the beginning of the description, and can make it wider. Otherwise, nobody can read it. Okay, this is the next paragraph. No, a bit more. Stop. So the chong, that one, yeah, is a agricultural machine that directly cuts or removes weeds between the rice paddy fields and the furrows. Now, I'm not sure about the translation, but I think it means what you're talking about.
Using a basketball.
Yeah, like I said, the translation is okay. And then it says that it's a type of cultivator that's pulled behind the tractor.
So perhaps, yes, the translation is really odd. Okay, I'm not sure what a basketball is doing here, but it's it's there might be something. For me, I've been living here for 3 years. Okay, and moving around and looking at what's happening. For example, this week I discovered this. Okay, it's a link I share here. I'm not sure what it does. Okay, so it's a robot in the rice paddies. Okay. And so, and I see people really struggling, and some other younger people too. Okay, struggling to cut this grass basically on the side. Okay, that just gave me the idea. Okay, we talked about rovers and rovers, for the moon and for some other extreme environments, about wheels, about legs, and so on. And the slope is such that I see that as a challenge, and I thought it would be interesting. Okay, but perhaps what Venkat is saying, is that from the paddy or from the road, and to have an arm going down, maybe one of the easiest way. Okay. So it looks like this Korean article is they're saying something similar. Perhaps is there any picture or?
今回はこちら自動浴槽ロボットアイガモロボの使い方というところをメインに紹介していきたいと思います。
It's called Aigamo Robo.
広がって太陽光を遮り雑草の発生や生育を抑えます。
It looks very big, not small like what you said.
So, but you can see maybe
GPS で位置情報を認識しながら自動で田んぼ内を泳ぎ
Use
回
the
ります。
sound of the video since none of us speak Korean anyway. You might as well talk about it.
So the thing that this is it's completely autonomous, huh? Okay, and so they put them in a paddy, and it's just going around, and apparently I'm not so sure what it does. I watched the video, but I was not listening to the sound actually. Okay, actually it's there is kind of screw under. Yes, we can see it here. There is kind of screw under it. Okay, and actually it's kind of mixing the water. So that some low grass doesn't grow aside side rice itself, something like that. Okay, So it's just roaming, going all around the paddy over and over. Okay, it has some apparently strategies to figure out what to do. Sometimes, okay, sometimes you can see bump on the a bit like a Roomba. Okay, it bumps against the wall. Okay, and it waits a few seconds. You can see it compute. There are LEDs. Okay, and after it decides to go left or right to do something. Okay, so basically it takes care of the rice paddy. Okay, we can see under the solar panel. Okay, the screws. Okay, make something apparently pretty useful. Okay. I don't really understand the logic inside it. Huh?
Okay, so now I have something in Japanese. I hope that's better. It's a patent called weeding equipment for waterways. And you see that picture number 5?
The pictures are down the document?
Stop, a bit to the left.
To the left.
Stop, that one, yeah. So maybe this is a concrete waterway.
Okay.
The weeder that goes in and cleans up.
Okay, so that's interesting because that would be an application like are we talking about doing self-driving cars, or are we talking about modifying the infrastructure such that automation happens? It looks like the second approach. See what I mean? Okay. So it can be designed to work in an open environment. Okay. So we don't touch the environment. We just make a.
Can you look at the text? Okay, you have that. You have to hide that funny window on the bottom. Yeah. And there's a section that starts conventional technology. Patents are very interesting. Yeah, stop that. Can you make it wider so we can read the text? Patents are interesting because they tell you what's done. So, yeah. So under such circumstances.
Where did it go? Okay, yeah.
So they talk about what things they have. And then if you continue on, there's a device for preventing clogging of the rice field supply. It seems like the problem is not only grass, but also garbage.
Yes, so the problem is clogging, basically. And the symptom can be grass, can be vegetation, or can be, garbage and so on, yes. You're right, yes.
Wait, so clogging of the river or water channel is the problem, not the grass on the sides by themselves?
The main problem is the clogging. The grass is also a problem because it's in the way. Okay, so it's in the way causing clogging, but also in the way of people walking around.
Anuraj, go down to where it says object of the invention. I think that's very interesting.
Eric, when you see this being done manually, where do the grass clippings go?
So
do they go into the channel or into the rice paddy?
So that's a very important point. Okay, that they collect it manually as well. Okay, so you see,
they pick it up.
Yes, they pick it up. A lot of a typical lawnmower, old style. They spit the cut grass on the side usually. Okay, so they make it spit away from the river, and after they pick it up. Okay, well, at least some of them.
Yeah.
Okay, so I don't know if you notice here, it says that we don't want to disturb the water. Now, I don't know how good the translation is. I don't know if they mean don't want to disturb it while we're cutting, or we don't want the garbage that we cut up to clog it.
Or anything you pull out of the channel you don't want going into the rice paddy.
Right. And one of the nice things about patents, if you go all the way to the end of, practically to the end of the document, Google gives us similar documents.
So just one thing that
a bit more. Yeah, stop. You see the first one, weeding equipment for waterways. Okay, so it puts us into the network of similar products.
yes.
But this is the same, no?
What the
This
one
figure
that
was
said,
the same.
yeah, they probably filed an improvement or something.
Okay.
It's for similar problems. There are different kind of solutions. Each of them patentable, right, Mayor?
Yes, but my I don't care about it being patentable. My point is, this is what people have been trying to do. And one of the things we're seeing, they're assuming that the waterway is made out of, the picture looks like concrete, but they're really worried about the garbage, and not only the garbage that we make, but also the garbage that, is made by, comes in from the road.
Right. Also the river comes from somewhere, so there is garbage coming from upstream every time. Okay. One of these rivers passes by my house, so I see that every day, basically. Okay. And so, but there is something also. There is one limitation with the patents as well, because they provide a logical analysis here. Okay. And I can confirm that what they say is also what people here told me about. People with these lawn mowers. Okay. Maybe from 50 to 70, a bit more also as well, people using that, okay? At the same time, it's has this patent led to anything that people actually use, okay? So that's something that we can't see in the patent, right? Okay? And so here, there is something perhaps interesting when we talk about rover, that is this a good problem for a rover? Okay?
Yeah, so I think you raised a point before which gets at that, which is if you have something like a concrete lined channel that suggests lots of state planned top down infrastructure, and for that you can have standardized solution. So if you have a different type of agricultural region with a different crop, and there's big central government concrete channels, you can have one type of solution. Rice, this is interesting because it connects up with some conversations I've been having in the summer protocols work, where we just did a workshop in Southeast Asia. One of the participants in the workshop, he actually just did a talk today. I'll share the recording later, but he pointed out that the culture of rice growing regions could be called something like rice punk. That's what he called it. And the reason is, as rice agriculture spread from southern China to Southeast Asia to India, Japan, all those places, it's a very labor intensive and kind of artisan type of crop, because it's very sensitive to growing conditions, very sensitive to topology, water, flooding, pests, all those things. Compare it to wheat, which is a kind of industrial friendly crop. It's much hardier. It grows very easily in large grassland type things. So people have done a lot of weird anthropological theorizing about this. For example, this is kind of like a essentialist claim, but the claim is that rice growing cultures often are really good at being detail oriented, but also extremely resistant to state authority being imposed on them. So rice growing regions in Southern and Southeast Asia have this punk culture of resistance. And the sort of technological manifestation of that is any techniques or methods of doing stuff when they spread from farm to farm. And remember, these are very small lots. Typically rice growing regions have small farming lots. When they spread, they don't blindly copy. They really skeptically evaluate, try it out on their local stuff, adapt it. So it's morphs more. This is true of all agricultural innovation spread. There's a book by Joel Moker called Liver of Riches, which says that in general, agricultural innovations, they don't spread through blind imitation. Farmers like try out new things carefully on their plot of land and then like generalize or customize. But I think even within that spectrum, I think rice and wheat fall on like opposite ends of the spectrum. So my hypothesis is rice is extremely artisan, and its rate of change from like plot to plot, like neighboring plot to neighboring plot, is higher than for something like wheat or other crops, because it's so sensitive and labor intensive that even your neighbor's plot may have slightly different like slopes and microclimates or something. So you kind of have to do some things differently. So the point of this is, if you have this kind of like punk geography, you could call it, I would say it's more rover friendly than the other extreme, which is kind of like civilized automation friendly. Like if you remember a while back, I led a session on like terraforming, like rover versus terraforming as a spectrum of like technologies. I would say this is actually a good problem, because rice, even though it's a crop of like really ancient civilizations, also happens to be kind of a punk crop that's, I don't know, creates cultures that are resistant to top-down, like large scale mass solutions, and does a lot of like local artisan stuff. So I don't know if this theory tracks for you guys, but it connects up to the conversation I've been having on the protocol stuff. Anyway.
Yeah, thank you. Super interested in knowing more about that. There is another aspect, because in the logical progression you expose right now, for me the conclusion is counterintuitive, because you said then rice is more interesting for a rover because of the punk. Okay, but for me, I would say no, it's the contrary. It's not. Why? Because it's very regular. Okay, let's take the Roomba. The Roomba is a success because there is somehow regularity across houses. Okay, and so that's why I would make that my naive conclusion. Okay, but at the same time, if we are talking about autonomous rover, okay, so with a certain degree of adaptability, yes, I concur with
saying. Like, the Roomba, I wouldn't call it a rover at all. I would call it an extremely specialized robot meant for built environments. And if you wanted to like innovate the Roomba in certain ways, you wouldn't necessarily restrict yourself to just making the Roomba more intelligent, right? You could do things like geofencing the vacuuming area. You could put like markers on your carpet. You could try lots of strategies, because the built environment is also part of your controllable area. Whereas rovers are designed for very open environments where you control the design of the rover, but you should assume that the rest of the environment is going to be wild and you can't really do much with it, right? Maybe long term you can terraform it. So that's why I think it's more of a rover problem. Whereas same thing with like, manipulator robots, humanoids, like I know Yasha just joined and he's anti-humanoid.
Welcome back.
I like humanoids because they also have this exact issue, right? Humanoids are very general purpose, but inefficient at any one particular thing. If you actually know your built environment well enough, like a factory or a warehouse, you would never use a humanoid robot. You would design something simpler, more efficient, and optimized for that. Whereas a humanoid is something like almost a rover that's adaptable across many environments. So I think something similar applies to, this looks very different from like a John Deere combine harvester with like 1 million attachments, which generalizes very well across all wheat and corn and soybean type areas, right? Rice harvesting is fundamentally different, and it looks like there's not, actually that's a good test. In combine harvester type technology for technologies like wheat, I think it's an oligopoly of like just a couple of manufacturers. John Deere is the big one in the US. I don't know what the rest of the world is, but in the search we just did, it looks like there's a dozen manufacturers of like these little rice harvesting machines, right? That itself gives you some indication of like, it's not friendly to uniform, I don't know, flat solutions.
I'd like to make a comment about the Japanese patent office. They like putting out reports. One of the things that they do is they suggest a way of mapping out patents in order to indicate exactly, Venkatesh, what you're talking about, how much innovation is happening in the field and how mature it is. And basically you make a chart comparing the number of patents filed versus the number of companies filing them. And at the beginning, when something starts, you have a lot of companies and a small number of patents. As the field matures, you have more patents, and then the number of companies starts going down. Then the field stagnates, and the number of patents goes down as well. and then when the field wakes up, they start filing more patents. So I put here a link to international classification of patents relating to growing rice. So I'm not charting it, but there's some interesting information here. And I think the most interesting information is that most of the patents don't talk about Eric's problem. They talk about, how do I grow rice better? How do I deal with heavy metal poisoning? Cadmium, for example. How do I plant the rice? How do I harvest the rice? And particular fertilizers.
I wonder if this changes as the population demographics of Japan in particular has shifted and become so older that is the labor force not going to be around to be hand mowing
But
these
Japan,
channels out.
it could be. I didn't tell him to show me only in Japan, but you know, Japan is, I don't know, maybe 10% of the rice growing in Southeast Asia.
Can you do the same search for wheat? Though Japan doesn't grow much wheat, so I don't know that you'll get many results. But
No, this is not Japan. This is European Patent Office. The answer is
okay.
yes. The answer is yes. Wheat probably has its own big classification. But what I really found interesting is that there are leading problems that people have been trying to solve in rice. For example, heavy metal. Okay, so in Bangladesh, that's a big problem. And what I'm wondering, or sustainability, you know, that rice paddies generate a lot of methane. So what I'm really wondering is if there's any way of solving two problems at the same time and use one of them in order to justify the technology we want to provide in the other one. Okay, I'm just wondering if it's possible that, for example, CO2 or methane or heavy metal collection, if you put that together with weeding the water canal. Yes, I don't know what you missed, but we're talking about the water canal that goes between the rice paddy and the road. And that water canal has very steep slopes, and if grass grows on that slope, and it does, the grass can clog the canal. So today they have people weeding it by hand, and it's, you know, not exciting.
So it's very interesting, Mayor, and I'd like to say something that today for this discussion, I thought it was interesting to discuss about the robotic rover aspect, okay? But in fact, there is something else, that actually I'm building this robot, okay? I'm just at the BOM level, I have some components and so on, but I'm building it actually, okay? But there is one of my goals is actually that there are motors for locomotion, okay? I'm trying to inspire myself from what we've done in this group over the years, okay? But the cutting component, okay, is actually with an engine that I'm working with someone independently, where this engine actually works with methanol and ethanol that I'm producing myself, basically, okay? Out of what? Out of the cut grass and home garbage, basically. Okay. So very interesting. You mentioned that. Okay. But for me, that's very interesting to think as a whole. But more the technology part, I'm trying to put that as an aside. Okay, by separating the locomotion on a slope, like we can see on the slide, and the aspect of cutting the grass. Okay, which could be many things, okay, another motor, okay. But here what I'm trying to do is to tune the thermal engine to be able to work right now with ethanol, but with ethanol, but also with methanol as well. Okay.
So do you remember that slug robot?
Which one was that?
There's a robot that goes in your garden and picks up slugs and puts it in a fermentation compartment, and it uses the fermentation of the slugs in order to power the locomotion of the robot. So what I'm asking is does it make sense to have device that goes in the canals and powers itself using the garbage and the weeds that it's collecting in the canals.
But conceptually, yes, but in practice, I think we are very far from that. Because, for example, ethanol. Okay, for me, I'm using the typical techniques. Okay, it can take several days to get a drop of ethanol, basically. Okay, so I don't know. It depends on such kind of dynamics. Okay, and for that, I just have no idea. Okay. But conceptually, yes, it's interesting. But for me, talking about that perhaps doesn't address the problem of cutting grass on a sharp slope, basically.
I dropped a YouTube link to a very US-centric version of it, which is cutting grass in the highway system.
So the Caltrans link.
Because wildfires are a big problem.
Yes.
So they have to manage the grass, and I've seen them do this with just a tractor and a mower attachment, and you'll be driving by and there's just grass going everywhere. It's a huge mess because they definitely aren't cleaning anything up.
So, this is where thank you for the link, but this is where talking about the root of the problem has a lot of impact on the design, because the video is really appropriate for large space, right? Okay.
Exactly. Yeah.
Against fire, but in Japan, everything is narrow. Okay, and by the way, a lot of people, when they go to a lot of Japanese people, the first time they go to the US, they feel lost because everything is so big. Okay, even when we go to the restaurant. Okay, I include myself because I've been here for most of my life anyway. So, and when I go to the US, I can't finish my plate. Okay, and so that's against my education. Okay, so that's why everything is so large. Okay.
So I'm looking at a Chinese patent, and it said, and I'll just give you the title: Rapid Slope Protection and Grass Planting Method. You plant the grass for drainage canal in farmland and black soil area. And what they're saying here is that we want to plant things in the canal wall in order to stabilize it, but we plant alfalfa and orneless, I don't know, and then you get high quality forage grass. So if you're going to have a robot going in that canal, instead of growing weeds and cutting them down, you can intentionally plant alfalfa or something else which has some forage value, and not just burn it or throw it away. You harvest it. Okay, so it's not just a problem, it's also apparently an opportunity.
Right.
And the reason that these channels are open in the first place is because they are also used for general environmental drainage for
Yes.
heavy water and everything.
Yes. It's a typical, geology. Basically, it's a valley, okay, where there is usually a slight slope down, okay, and they modify the land to have this stair-like structure, okay. And so naturally, of course, the water goes down, but they want to keep that under control so that they can build houses without any risk of flooding, right? And so there is this basically whole really artificial network of small rivers, basically. Okay, so usually there is a big river along the valley. Okay, and all this network, for irrigation, okay, that goes back to the main river. And so there are two goals: is drainage, as you said, plus the taking care of the rice paddies. Yes.
And by the way, this Chinese patent says, I'll say it the opposite of what you just said. That one of the problems is they want to avoid soil loss, and they also want to slow down the draining of pesticides from the grass field into the river. Okay, so pesticides washed into the ditch by rainwater are blocked, and the pollution of the pesticides to rivers is reduced.
Okay.
So it's not just we want better drainage, there's a balance here. And of course, some people grow fish in the ditch.
Okay.
So all I'm saying is that it's not taking what Venkatesh said. It's not that we have a ditch, but the ditch is really an integral part of the system, and it has a lot of constraints and uses that it has to take advantage of. And in each place, they do something different with it. Some place they want more drainage. Some place they want to slow down pesticide. Some place they want to grow fish. So yeah, so it helps kind of define what we're allowed to do and what we want to do.
Definitely, that's the concern of the environment and robotics, right?
Yeah,
but it's
the opposite, perhaps. If people want to do so many things with a ditch, making a robot might be the way in which we can support different things. If you want a ditch that flows quickly, you do setting one on the robot. If you want the robot not to interfere with fish growing in the ditch, you use setting number 2. If you want the robot to help cultivate alfalfa, it's setting number 3, and so on. So that kind of justifies using a robot as compared to some sort of agricultural equipment, that you drive on the road and you have something pulled along by a car inside the canal. It's like the opposite of a canal barge.
Okay. The broadness of features you're talking about seems to link to the punk aspect that Venkatesh was talking about earlier. Okay.
Yeah.
And so, are we saying that basically just this problem of cutting grass on a slope, okay, automatically with some robot or rover, okay, is actually a much bigger problem? Should be approached as a much bigger problem?
It's definitely a bigger problem, because what you described as cutting grass, it's not like on the highway system in the US, where the goal is not to have grass. Here, the goal is to have a ditch which does all sorts of things. And maybe it's growing shrimp. Maybe you want to get out leeches. There's all sorts of stuff people do in the ditch.
Right. Yeah. In terms of engineering, that sounds suddenly so much more complex than what I had in mind, before starting the discussion.
but you wanted a robot. If all you wanted was to cut grass, then you would have had a tractor driving on the road, okay, and it would have been pulling some sort of implement with the correct shape through the canal, cutting grass and collecting it, and sending it back to the road. That's a natural solution. But you can't do that, because you have to be much more sensitive to what's happening in the ditch. And robot is an answer for what you do, and Joshua will correct me if he disagrees. A robot is a solution for what you do when the problem is not so well defined, because if it were well defined, we would just mechanize it. So here the problem is not so well defined, and we are talking about mud, So.
The main reason the slope mowers exist on the highway system is risk of rollover, because there's a lot of inclines where the tractor is simply risk of operator injury, up to and including the point where like even the remote controlled slope mower can roll down the hill and have an incident. There's this one company, I think they were called Spider mowers. Spider slope mowers. They're kind of like the one's been around a long time. Because I think they were like one of the first successful like remote operated. Because somebody like this isn't a robot. This is a there right there in the marketing. They've got like you sit there with the fanny pack joysticks and you control it. But if it rolls over, as long as you're not standing on the bottom of the hill, you'll be fine. And this one, you can even see this one has a winch, so you can actually put a stake at the top of the hill, and it will use its little winch to ensure that it always is backed up on the hill, even if it was going to roll.
They are big, huh?
It is. That's right. That's right. It's big. It's a big, kind of scary thing, and yeah, for the U.S. highway system, for visibility, and then for California with the wildfires. The rice stuff is interesting though, because mud is really hard. I mean, mud. Yeah, mud's a lot, especially for a robot. I'm trying to think of any muddy robots. I really don't think I can't name like a muddy robot.
We can see that one, the spider, here in the mud.
Yeah, but
Yeah.
we don't want it to be quite so muddy, because if it's muddy, then the dam falls down. So the dam wall is made out of wet dirt, but people can walk on it, so it can't be that muddy. And we have the canal itself, so it could be that we want to keep some of the grass in order to have something stable to work on. I don't know.
So I confirm from what my observations, but there is one thing is access to the field. Okay, and so there is always those small passage, where the robot can access the river. Okay, but when I say the robot, it's just because there are small tractors, the devices we saw earlier, so such kind of device. Okay, and those can be pretty muddy, basically.
Mm-hmm.
Yeah.
Oh, look at all that marketing.
So, for the mud, isn't it common to have caterpillars then as a solution?
But you can't damage the dam. Remember, if you damage the dam, there's going to be a lot more work fixing it.
Yeah. Yeah, weight is an issue, definitely. Yeah.
So can it float in the little trough in the water? Can it have little arms and it clips, like gives a trim?
Yeah.
Or like what's the...
Yes, and there will be two ways. Is either a rover with arms, or as Venkat explained earlier, that there are all those devices, at least in Japan, where you can fit different tools on the machine. Okay, and so to build a tool on those machines that goes directly inside the paddy itself, and it would be like some kind of an arm, okay, going down inside the river on the side to cut. So yes, those options. We can think about them. But then the question is that is an arm durable enough? Remember, Joshua, we talked about the trade-off between legs and wheels and such kind of stuff, depending on what we do.
Yeah. Yeah, the humanoids, they're just everywhere around here. Like, they're just all over the place. They seem, especially they hang out in the South Bay. Somehow it's like, Mountain View, Palo Alto is like the epicenter from which they emanate.
Every Palo Alto garage has a
An
A
arm.
humanoid robot being built.
Yeah, at least an elbow.
How is the hardware evolving? Do you see any kind of trend? Because a few months ago that everyone in robotics would say, okay, the arms are too weak, or the basically the whole thing is too weak to be really useful, basically, or durable. Okay. Is this changing?
I mean, I think the way I would immediately answer that is no. No, I really don't think it is. There still hasn't been like there's kind of like I feel like it's a bit of a binary kind of application space still. It hasn't. I don't feel like it's changed that much because there's kind of like let's call it the PhD or researcher setup, where you get some dynamixels and you have some degrees of freedom, and you can have a small payload of like below a kg, and you can do some stuff. And then you're actually on the other side, you're actually building a thing that can lift a payload and do a lot. But there's still like the thing about actuators is we've had no fundamental breakthrough in magnetic materials anytime in any of this. So it's still kind of like, and same thing with gears and gearboxes. No fundamental like materials discoveries there. And in fact, the thing that's crazy to me is how few new superconductors that we found in all this time. Like it's actually insane, like how short that list is. And so these actuators are still all thermally and like limited by materials, and the gearboxes are in the same boat. So it's not like the humanoid robot form is at all unlocked by physics lately. I do think Asia is making more and more cheap gearboxes. So there are people who are buying cheap integrated servo gearboxes that are in the form factor, which is highly useful to build the knee and the elbow and these things. But there isn't any like unlocking force at play. Yeah, I mean, to me, it's just kind of like it feels like it's a race to the bottom and commoditizing the actuators, like as more and more people are buying them up. Because it's like because I feel like what's happening right now with the humanoids is what happened with quads a while ago, which was there were a few people that built some custom gearboxes and motors, and then they like published a design, and then Asia started making a bunch, and then there was kind of like that ecosystem of clones of these QDD actuators that are really good for legged robots. And then you have lots and lots of those that are available that people use. And now the humanoid people are in the same boat where you can buy 24 integrated servo actuators from Asia and 3D print the rigid bodies that connect them, and you've got a humanoid. So it's yeah, I'm sorry, that's kind of like a long-winded rambling thing to say that I think the actuator technology is fundamentally unchanged. It's really, yeah, I feel like it's still in the software game. But whenever I talk about humanoid stuff now and and humanoid people, I'm always wondering about like the what I view are the, and this is a commonality to a lot of like all robotics as a business. That is, it's like there are rings of fire that exist after you have the robot working, because a lot of the energy and focus on humanoids right now today is still like getting it to stand up and like pick up the banana. But like the autonomous cars rolling around the city right now, nobody notices them anymore. They're like ambient. They're just part of the scene now. And I think the only thing people care about an autonomous car in San Francisco right now is like, is it blocking traffic and is it giving me a cheap fare across the city? So the next ring of fire for humanoids is them actually doing, like do they have like enterprise management platforms that work well with your existing workflows and data and all this like integration stuff and user interface stuff? I think that's kind of like where that's like the one step ahead of where most of the humanoid robotic stuff is right now, that some people are of course starting to get to, but there's a few people maintaining like big spreadsheets right now that show like all of the companies and like what they've done in terms of key milestones, and like they're all just starting to hit the pilot deployment hell, which is like notorious in robotics, where you get the first deployment, or if you get the first pilot, but then like you got to convert that pilot to a contract, and that's where most people die. So it's like getting out of pilot hell is what we're just starting to be the main set of problems for humanoids, and that's where I think it's going to start to be way more interesting. But I don't know. I still like I do like the rice canal thing because it fits into my whole Star Wars narrative. Because I think you roll up to the farm and you have like weird looking, like it'll have half an arm and like a stick, but that's exactly what it needs for the task. And once we're past this whole like starvation of training data thing where we can just like arbitrarily like you train on all of YouTube, right? But you don't have to actually deal with, because I think a lot of people are like, oh, if you're training on all of YouTube, you have to actually like map to the same kinematics of like a human, because that's like the main sample. But what you care about is like what the human's doing and how they're interacting. So I think like once we figure that out and get past it, then we don't have to have just C-3PO. We can have like all the weird droids that are the right thing for the ditch or for the tree or whatever it is. Tree trimming is that's a really big one, by the way, especially in California, in the power lines. So the plop plop plop. That's one. That's another one that you don't need legs, but you could have a torso and arms, I guess, if you still want to throw a humanoid up on a stick. Like that's fine.
Have you seen the Japanese robot? Huge robot. I think it's 12 meter high. Okay, that takes care of the power line for trains in Japan. Yeah, I think 12 meter high, and it looks like if you know Gundam or Macross. It's we're in Japan, okay, so they love that. It really looks like that on purpose. Okay.
Someone better find a video of that right away.
Yeah, I saw it. Yeah, exactly.
And so it's remote control. It's remote control, okay, but it's. I remember seeing that maybe a year and a half ago. Okay, so one of the first tests. And someone puts like some kind of VR set, okay, and it's inside this big, and it's really moving big pieces of metal, okay, and so they can mount also a circular saw, I think. Oh, wait, this one, yep. And so they can mount a saw as well on the arm to.
This is awesome.
Yes.
The head is really small.
Yeah. And so
wait, did they show the operator console though? I gotta see the operator console.
I remember seeing that back then, okay. But there was a new news. There were news, I think, last week. Okay.
Yeah.
Oh yeah. Let's see here. Okay. The cockpit. It's at the bottom of the truck that brings the robot, basically. Huh?
Yeah. Here's the count.
It really is like anime.
Yeah.
Honestly, I don't think this is a practical solution. They deliberately did this so it would look like the comics.
Okay, it says early 2024. We are in early 2024. So did they?
Yeah, they've done their first contract recently. Okay. Yeah. So, but it's a deep in the psyche here. You get to have these big robots. That does work, okay? Perhaps you heard about, iSpace, the company that sent, that was on the Google X Prize, okay? They had their small rover in the final called Hakuto, okay? Hakuto means the white rabbit, something like that, okay? And so that was backed by a very large part of the population, okay? They made some crowdfunding to be able to continue on that competition, okay? And that lasted for 5 years. I was part of it, okay? Got T-shirts and all that, and some of my friends worked directly on the robot itself, okay? when you look at it, it looks like not so much, but it's huge. It was a huge engineering. Okay. After that, they got $90 million, and they never managed to send it to the moon. Still, okay. So every year it will be next year. Okay. So hard, right? Okay.
Yeah.
But it's all the narrative about the robot and so on is really, really here, deep here. Okay. Yeah, you have anime from the 50s, with robot boys, little boy and so on. Okay. I think it's called Atom Boy in Japan. I don't remember the name in America. Okay.
Yeah, we have 15 minutes
I
past
know.
the hour.
Just 1 second. If you could put up the pictures that I gave, where it says here, it says 3 links up, just so we'll.
And also, do we look at the Venkat's Lego?
Yeah.
The Lego, Venkatesh?
Oh, that I was just fiddling. That link I posted. Let's defer it to next time because Yasha, you made an interesting comment about how the humanoids are now facing the same problem
right corner.
what you guys did
Right
before. So that link is relevant, and we can discuss it next time. But yeah, we should do a similar session on like drone delivery.
Yeah, that's a great. Yeah, that's a good one.
You mean the one that drops eggs on your driveway?
It's kind of similar, actually. Okay, so I'll give you the 60-second version. We can do a full session on this later. So the problem with regular drone delivery with the quad type designs is that the power to weight ratio is like off, so very sharply limited. So Yasha's point was no progress in mechanical actuators, magnetics, blah, 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 right? And with drones, a similar problem is these quadrotor type drones can't carry very much. Now, lifting bodies are interesting because they're basically like... they don't have wings. The body itself is the lift providing thing. And they were initially invented for like re-entry from space. So the wings don't shake off, right? But the interesting thing is they also have very high internal volume and payload capacity and can move at very slow speeds. So this is a friend of mine, Star Simpson. It's her startup. And they are just like taking a NASA design and rejiggering it for like drone delivery, and it can go like at bicycle speeds. It can carry half its own weight and payload. So that if you look at the last thing, it says that. So this might be the actual like bottleneck metric to look at. So I think there's 2 interesting things going on here, right? On the one hand, robots are at the other extreme from automation in that they're not single function, they're multifunction. And then rovers are even more extreme. They can be in open environments and do anything. And then if you throw in machine learning, they become extremely general purpose, physical problem solving devices. But they usually will still have like a single bottleneck constraint, right? So for legged robotics, it's like maybe the power of hydraulics is the limit, or weight of hydraulics rather. For motor driven things, it might be magnetics. For aircraft, it's I think the dead weight payload to like a vehicle weight ratio. And this is a way of like breaking out of that actuator bottleneck. So it's you no longer have like the very precision delivery model of quadrotors, but if you can very, very slowly drift over an area and drop it within a 3-meter square area, and you like sufficiently pad your package or have some other mechanism to keep it safe, you can suddenly now carry a lot more, right? So I think we can apply the same logic to things like rice canal cleaning. Like cutting the grass is one problem, but there's a million other problems. So you want to like solve all of them at once. But then you have to ask, all right, in that whole envelope of problems, what is the bottleneck design variable? Is it power? Is it weight? Is it speed? So actually, that would be an interesting question to ask about your rice robot. Like if you had to design like a completely general rice robot, what would be the limiting like input variable? Anyway, yeah. So tables for future, the drone problem.
Yes. Do we discuss that next week? That's an interesting one. I have several questions actually.
Yeah. This is all I have. This one link. All right.
Okay. See you next week.
Okay. Bye. Good night.
Bye.
Bye.